All right. So what are we going to talk about? Well, we've got about 2.5 hours for this webinar today. And just know that there's a lot of space in that 2.5 hours to answer questions, to attend to your specific concerns, and for us to kind of meander and wander through the vast ecosystem, just the app hosting and the data store hosting portions of AWS. So to that end, we're going to basically, in part one, we're going to spend some time talking about application hosting and what services are available. I will give you some limits, by the way, about what I mean by that. And then in part two, we're going to talk about how they compare. I've got a simple little rubric that shows kind of a subjective qualifier of technical overhead and support and other aspects of how we would compare these things, but also when you would want them. When would you use, for example, Elastic Beanstalk versus Lambda, right? When would you use the DocumentDB data store versus, say, the managed Cassandra data store? Some of that is self-evident, but we're going to call it out just to make sure. So we'll do about 45 minutes of app hosting exploration and then 15 minutes of comparison. I'll leave 15 minutes for a break, so we will take a short break in about an hour just to give everybody room to breathe, right? Take a biology break, whatever you need. And then we'll spend another hour going through data store services. And that could go faster or slower just depending on the number of questions and what we have going on. And then we'll close. All right. So I'm going to lower all the hands. If you can see my screen, please raise your hand and just let me know that you can see what's happening on the screen. Just something worth confirming. If something were to happen and all of a sudden you hear me pause for longer than like 10 seconds, don't worry, I'll jump right back on. But sometimes that happens where we lose connectivity. Just give me a second, I'll be right back and we'll get reconnected with you. Okay. So what about the scope? Because you said apps, you said data, right? And then you qualified it with data store, right? Well, what I'm talking about is when I say applications, what I'm referring to is services that host and run code. Meaning I can either upload code to them in a bundle, like an artifact, like a zip file, jar file, war, etc., right? Or I can put them in a container and upload the container to the application hosting platform. Or I have access to the operating system, and therefore I can put it in any of those formats, or I can just run it natively on the system because I have access to the OS. So that's what we mean when I'm talking about the services we're going to cover today, is I'm not going to cover anything that actually can't host and run code. So for example, I'm not going to talk about S3 static websites, because while it's true you can host JavaScript files there that people can download, you can host artifacts there, right? That's static and it's not a platform that's going to run them, even though a lot of that will run into the client browser, right? So I'm not going to talk about S3 static websites, but just know that's an option. I'm also going to not talk about tooling like API gateway or proxies like the Elastic Load Balancer. They, in a sense, either run cache copies of code or they are just proxying code or applications of some type. So I'm not going to cover that either. And in terms of services around data, I'm only going to talk about services that host data stores. So that means an active running application of some type that serves out and hosts data, right? So it also hosts and runs data. So for example, I'm not going to talk about Athena, right, which is the kind of SQL query engine that you can run against S3 structured files. I'm not going to talk about QuickSight or Presto or anything else that in a sense is more of either an enabler or a tool or some kind of presentation window into data. I'm only going to talk about the database engines and services themselves. To that end, I'm also, just to mention, excluding streaming, and I'm going to exclude the ledger database, which most people don't even know exists on AWS, but there is a ledger database that's actually relatively new, the QLDB, which shows up in the menu for the list. And I'm not going to talk about Kinesis or the managed Kafka service or any of those style of data stores. I know that some people would probably want Kafka in the mix, but it's a relatively new service. So I usually only talk about things that I have production experience with. So the managed Kafka service, which just got announced here within the last 2 months, that's not yet in scope for this conversation. All right. I'm also going to do tools, no add-ons, no networking. I think I covered that adequately. Yeah. Okay. I'm also going to talk about pricing. So I just told you what I was going to talk about. I told you why I wasn't going to talk about other things. And I just want to mention is that we're going to go through a lot of websites around pricing. But I want you to know that pricing changes frequently in your favor, because Amazon, about once every year or 2 years, consistently lowers prices on things. The other thing is that I'm going to have a lot of reference links to documentation in my presentation today, and we're actually going to look at a lot of that documentation, because I want you to know where to find the answers, because the answers change a lot. So especially when it comes to why you would use these services, I would say most of that isn't going to change a whole lot. I'm giving you a rubric or a guidebook, if you will, about which app hosting services to use and why. But the pricing and a lot of the technical details of those services will change quickly over time, because Amazon, if I remember correctly, is doing like 1,100 deploys a day. They have 6,000 services across their ecosystem. And, just to mention, that's a lot of change every day. Some of those are bug fixes, some of those are feature enhancements, and some of those are improvements for the customer. So just know that after we leave here today, you want to remember that there's links and documentation to give you very specific technical answers, but the why you would use the service is going to be very useful for you if you're not familiar with the AWS ecosystem. So to ask a question, raise your hand if you have any prior experience with AWS in production in your portfolio. Like if you've ever been part of a production team, either as a software engineer or QA or DevOps operations, or as a Scrum Master, project lead, business analysis, if you've been participant in a production deployment to AWS, raise your hand for me. Oh, good. Okay, good. And I think you're in the right class, because this is really an introduction to the ecosystem. And so it's going to explain a lot for you if you've never done a production deploy, especially the fringe services. One last question. Raise your hand if this is like your first time, actually, you're just getting started with AWS. Like this is like your first time even taking a webinar or foray, you barely touched it, you're really just getting your feet wet for the first time about AWS. Oh, excellent. Absolutely love that. You are absolutely in the right place. So perfect. So welcome. I'm glad you're taking the foray, because I think you're going to absolutely love this webinar. It's going to be very simple. There's going to be some repetition in there, but I like to make sure that we repeat things so they get driven home so you don't forget them. One other word of caution before I dive into the rest of this around pricing and pieces like that, or one enhancement, if you will, is that you are literally giving me, in a sense, the greatest gift, in that you're giving me your time and your attention and your focus. So just know that if you really want to maximize your attention, it's not going to bother me either way, because most of the webinar is one-sided, and webinars typically are, where I'm not necessarily going to get a tremendous amount of feedback from the participants except for questions. So what I would ask is that make sure that you are focused on what we're talking about. And if you want to maximize the time, the gift, right, as far as spending your time here with this webinar, get out a notebook and just take notes. And doodle while you're taking notes. Like while I'm in between, nothing substantial is being, just doodle. And then what will happen is that you're going to see a 30 to 50% retention in your learning just by taking those handwritten notes and activating the body and just keeping your focus on necessarily like what I'm saying and meandering around what I'm saying. But don't let emails and kids and dogs, if they can, like distract you if you're in that environment. So if you want to maximize your retention, those are my recommendations. Okay, now you'll see that I was talking about pricing, right? There's many dimensions to pricing, and I want to mention a few resources. So there's a link inside the slide deck that talks about, let me pull this over actually so that you can see it. And this is like the Economic or Cloud Resource Center inside AWS. This link is obviously in the slide deck. And it's going to talk about things like the simple monthly calculator, the total cost of ownership calculator. I will tell you there's a bunch of really great stuff here. The thing that I would want you to most pay attention to is the simple monthly calculator. If you've never seen the simple monthly calculator before, it's one of the oldest tools that AWS publishes, and it is tremendously useful. Why is it useful, you might ask? It's useful because as we run through the pricing documentation, you might not be able to find the quick links for the documentation. But if we're talking about EC2, for example, and you're like, I want to know how much a virtual machine, which is what EC2 is, the virtual machine costs in EC2. And so what you do is you come into the calculator, you pick your region. And so, for example, you might pick North Virginia, which is the first and the oldest of the regions that you can put servers and services in AWS. And you might come in here and you might add a new row and say, look, I got a project, it's called Unicorn, and it's going to have about 10 instances. I expect them to be used 100% of the time. And you know what, we're going to choose something really like significant. So I want something beefy, like a compute instance. And I'm going to choose some C5 extra larges, which is probably one of the largest compute instances that you can choose, right? And I'm not going to do anything different with billing. I'm just going to kind of stay with the billing that I have. And then next thing you know, it's going to update your bill and tell you how much that's going to cost you per month. Now, you might look at that and you might say, oh, Michael, you just gave me sticker shock. I'm going to pay $32,000 a month for servers. Just know that I picked the largest servers in the compute family that you could pick. Most of the time we run something way smaller than this. We don't actually choose the largest and most, biggest servers we can. Just know, and I'll talk about this again when we get to the EC2 service. Like for example, if you were going to do a proof of concept, you might do like the T series, right? And as you can see the number of processors and the amount of RAM that the systems have. And you might be like, well, you know what? I just need, 4 cores and 16 gigs of RAM. So I'm just going to use this one as a proof of concept system. And notice what your costs are there, right? It's just $1,300 a month for 10 boxes that are 2 by 8 cores. So the monthly service calculator, which is what the point of this entire thing is going to teach you what questions you need to know to price your bill appropriately. So in this case, you may not know that, for example, you need to choose a system type. Windows, by the way, costs a little bit more. I'll cover that in EC2. And then you might not know the billing options for EC2, but guess what? If you come in here, it will teach you what that is, right? So that's what I love about this simple monthly calculator when we talk about pricing, is that it will actually show you what it is that you do or do not know for the dimensions of pricing. For example, if I'm using the T series, I'm also going to need an EBS volume, which is the virtual hard drive service. So let's just say this is also for the Unicorn project. I'm going to need 10 volumes, right? Since it's Linux, I'm just going to use the standard SSD, but I'm going to have the standard drive size. Let's just say 30 gigs, just to be nice to ourselves. And I'm going to take one snapshot, or let's say 30 gigabytes a month, so one snapshot a month of backup storage for the operating system. Notice that my bill went up a nominal amount, so $1,386. Without it, it was $1,339. So just remember, this AWS Simple Monthly Calculator will teach you the dimensions of pricing that you might need to know, and you can find it off that link I sent you under the Simple Monthly Calculator linked here, or you can just Google it, quite frankly. It's really easy to find. Good. All right. So let's talk about the AWS service set. So, way back when the service set looked like this, and yes, I know that's a blurry picture, but I don't mean for you to look in detail about what's available. This is like a couple years ago, right? A couple years ago, this is what we had. And then AWS grew, and then it grew some more, right? And then it got even bigger, and then it's like, holy cow. Wow, we've gotten huge with our ecosystem services, right? So what's funny about that is that now we're up to a remarkable amount of Amazon Web Services. But what most people don't realize is that most organizations use the same set of services with a couple of one-offs, right? So they're not necessarily using, for example, App Mesh or Cloud Map, or they're not using like the IoT Core or any of the IoT, like they're not, they may not be into that space, right? So just know there's an overwhelming amount of services. And if you look at the console, where did I stick my console? Over here, right? If you look at the console, the number of services that are in the service console here is significant. It's massive. There's 6,000, in a sense, kind of micro style services that are here that feed the entire Amazon ecosystem. So don't get overwhelmed by that. We're only focused on two sections. This section on compute, and this other section on database. All right. Any questions thus far? Let's see. Unable to see your screen, only able to see the PowerPoint. Oh, well, let's see if we can shift that. Thank you for saying something. Let's see if we can make sure see if that happens. So you can see my screen now. Raise your hand if you can see my other screen with the services listed. All right, good. Sorry about that. I'm not sure what happened. Okay. So, and just a reminder, if you click on that link under pricing, that will take you back to the AWS Simple Monthly Calculator. All right. Okay. So obviously now this ecosystem of AWS Web Services has gotten super large. And by the way, they're not the only ones. Like this is the CNCF landscape website, right? This is basically showing everything that's in the kind of CNCF's like purview in terms of like associated, ecosystem. Just know that like by far Amazon's not the only one that's exploded. They've all exploded to a certain degree, right? So our topics today for our compute discussion is our EC2, Lightsail, ECS, EKS, Lambda, and Elastic Beanstalk. Well, what are those? We'll go. Don't worry. We'll go through them. We'll make sure that we can answer, right? So, but that's what we're going to cover. But I'm not going to talk about ECR, which is under compute, but it's really a tool because it's the Elastic Container Registry. So you use that when you are using containers, but it's like an associated tool. I'm not going to talk about batch because that's for batch jobs. I'm not going to talk about the serverless application repository or AWS Outposts. The serverless application repository is just like a repository for serverless applications and their templates. AWS Outpost is so that we can put AWS into your data center. So if you want to run AWS physically in your data center and extend cloud into your private data center, that's what AWS Outpost is. And the EC2 Image Builder is a tool to build installation images for your EC2 ecosystem, and EC2 is the virtual machine system, ecosystem. So think of that as a virtual machine image builder, right? Let's see. So Ramesh, just to check, when I switch to a different screen, are you able to see me switch? Ah, okay, good. Yeah, so I switched it before. Good, I just want to make sure that we got that fixed before we move on, because I will be clicking in and out to a bunch of different links. Cool. All right, any questions about where we're headed? Everybody's looking good. Raise your hand if you feel like we're headed in a good direction with app hosting. Excellent. Good. Okay, so let's talk about the most common service that everyone seems to touch outside of S3, which is the simple storage service. The most common service everybody touches inside of AWS, which is the virtual machine service. That's all the Elastic Compute Cloud is a virtual machine service. And I don't want to minimize it because AWS, Azure, Google Cloud, they all do things very differently. But once you get access to an operating system, it's pretty much the same, right? They all, we all come with different flavors and styles of operating systems. So EC2 is just running virtual machines in the cloud. So I think the only thing I will mention is that if you want to make sure that you run your virtual machines very differently in AWS than your virtual machines run when they are in your data center. And the reason for that is utility computing, right? So AWS allows you to pay for what you are using and then give back, items, services when you're no longer using them. So just a word of caution is that EC2 is going to figure for app hosting and for data store hosting. So you can roll your own virtual machines inside of AWS, but don't run them like you run virtual machines in your data center. These machines need to scale up and they need to scale down. And if you're not being elastic with your virtual machines, you're probably inefficiently using AWS. So just something to keep in mind is that you want to make sure that you are embracing elasticity if you use a virtual machine service, EC2 in AWS. That being said, this is one of the oldest services in AWS, and they iterated upon it a lot. Its footprint has expanded tremendously since the 2007-2008 timeframe when this really hit production. And because it's a virtual machine service, you can run Windows and Linux of any flavor. You do get access to the operating system. And you can host practically anything, right? You can host practically anything in the system, right? So don't feel like this is like your most flexible option. It also comes with the most overhead. So you're going to be responsible for the security and patching of the operating system. You're going to be required to support and manage the fleet of systems. In return, you're going to gain a lot of control and a lot of technical flexibility, but your costs are probably going to be the highest, not because the AWS costs are going to be the highest, but because you're not offloading any manpower, right? This is an infrastructure service with AWS, and when you use this, you are just running virtual machines the way we've always run virtual machines. But here's the cool thing. If AWS doesn't have a competing service to run your application in another format, or you've got some kind of custom or complicated setup, virtual machines are always an option. You can always go back to them, right? So just know that this actually gives us the most flexibility, but it does come with the most overhead, right? Just to check, because I see Ramesh is having some lag time, is anybody else currently seeing my Elastic Compute Cloud slide on the presentation? If you can, raise your hand. Okay. Yeah, Ramesh, I'm not sure why there's a lag time. Since there's a number of other people who are seeing it in real time, unfortunately, I would probably look to the internet connection between us. Unfortunately, I can't stop to troubleshoot, so I apologize. There will be, the slide deck is available in the chat, so if you want to pull up the slides, I'll make sure I call out the slide numbers so you can see exactly where I'm at. So you can pull it out in the PDF if you want to run through them. Okay. And Stephanie, just to mention this, is that the PDF slides are, the link is right there. Carling just posted it into the attendees, so feel free to grab it there. All right. Now, documentation-wise, coming back to the virtual machine service, there is a ton of documentation on EC2 because guess what? EC2 is an older, well-known service that has had a lot of investment and iterations upon it. So you've got user guides for Windows in the documentation set. So hopefully you're seeing, by the way, the Elastic Compute Cloud documentation link that I just clicked on from the slide on EC2. They got a command line reference. There's an API reference. There's a virtual machine import export guide listed here. So there's tons of really great documentation for this particular service. Now, pricing. How does pricing work for if you're going to host your application on a raw virtual machine, well, first of all, just know that there are tons of like licensing models that you can follow. Most people follow the on-demand licensing model. So even if you're in an enterprise, like if you're in an enterprise, you might have a reserved instance model, but most people follow the on-demand model, especially if they've got a frequently changing environment. If you have an enterprise agreement with Amazon, you're probably using a reserved instance agreement. You might be using a savings plan, but most of the time people are using on-demand or they're using reserved instances. Spot instances and say like dedicated hosts and all that, those are all special use cases and types inside AWS, but your pricing is predominantly determined by the size of the machine that you get. Let me show you what I'm talking about. So if you look at, there's a special website called ec2instances.info, and I will actually post this into the chat so everybody can see it. And ec2instances.info will give you a very easy to look at, but very full kind of table of how you would do costing. So let's say, for example, in our early example, we're doing a proof of concept and we only want to use systems that are of a family type of T3. Now, slowing down for just a second, when you look at what the T3 type gets you, I've got two virtual CPUs times 4 gigabytes of memory. And look at what that's going to cost me. If I use Linux and I don't get into a contract with Amazon, it's going to cost me a little more than 4 cents an hour. That's pretty cheap, actually. That machine will probably cost you, just slightly south of, $25, $28 a month, plus EBS, plus data transfer charges. And if I'm using Windows, by the way, the cost is going to go up to about 0.06 cents an hour. Now remember, there's about 730-something and 740-something hours per month, depending on whether it has 30 or 31 days. So, the hourly cost, this is how you figure it out with the EC2, is that you're going to look at the size of the machine that you need, right? Do you need a 2x4 medium T3? Do you need a 4x16 gigabyte T3X large? Do you need to go even bigger and go for an 8 virtual CPU 32 gig system? No, this is probably what you're going to look for. The only catch, by the way, is that EC2 has a number of different family types of systems, and some are optimized for compute, some are optimized for memory. And so you want to look up these machine types if you're going to host your application here to make sure you're getting the best value for the CPU and the memory ratio that you're looking for. Does it sound complicated? It doesn't have to be. Let me make it simple for you. Let's say that your server documentation for your app says, you know what, I need 8 gigs of memory, and I need a minimum of 4 virtual CPUs, right? Well, guess what? You just type in 8 and 4 into virtual CPUs, and there we've got an infrastructure. That might be a special box. Maybe we'll ignore that one, right? But then look, here's a C5. A C5 extra large would actually fit that scope at 17 cents an hour. Or you're like, you know what? I actually don't need 2 virtual CPUs. I probably only need 2. Oh, good. Well, let's see what we have here, right? So I can use an M4 extra large, but just as a word of caution, you want to use the latest generation. So I might look for an M5 instead, which is there's an M5 down here, right? Or I might look at an M5D, which is different like processor and GPU type, right? And so I might look for the right system, and instead of looking based on family type, I might look based on memory and virtual CPU footprint. So I hope this leaves you with an understanding that EC2 is indeed a great hosting option, but it comes at the cost of the most overhead, and it will give you the most technical flexibility. But you really have to like administer operating systems and virtual machines, and you're not gonna offload any operational overhead. The other link in the slide deck is to the facts. So if you have questions about the different instance types, for example, we have accelerated computing types, we have P3 types, we have M5s, we have C5s, like there's different types in here. And so if you need to understand this better, every single one of the services we're going to talk about today comes with the general documentation link, a pricing link, and a frequently asked questions link. So you're getting a treasure trove of information today that will help you navigate what we're talking about. Good. The next thing I want to talk about is something that came out, I want to say a couple years back, maybe it was 2016. It's called Lightsail. Lightsail is kind of a VPS, like a virtual private server version of EC2, of the virtual machine management system. And most people don't use it, mainly people who are looking for like hosting options that are really like flat in their variability and pricing. There's not a whole lot of randomness in the pricing, and everything's kind of like bundled into a package. That's Lightsail. Lightsail, by the way, doesn't have as much of the management interface features that you would find with EC2. It really is Amazon just giving you root access to a server of a certain size. So they typically are smaller, they're more unmanaged, but you can actually use pre-configured templates like WordPress, for example, to manually host your website or your services. So it can be super efficient, but it comes at the cost of slightly more management overhead, but this is a much smaller system. So, you know, still you got to patch it, still support overhead, but you get a little, you know, more infrastructure control and you get more technical flexibility, and the cost is way cheaper than EC2. So you get, in a sense, slightly less of everything, including costs. But that's what Lightsail is for. Lightsail is really for virtual private hosting. It's really not necessarily for enterprise applications. So I wouldn't necessarily look at Lightsail for that. Again, there's links here for the Lightsail documentation. So if you want to know more about how it sections things out and what use cases are best for it, there's pricing here. So as you can see here, for $3.50 USD per month, you can get a 1-core 512 memory system with 20 gigs of SSD space. So Lightsail was really made so it could compete with web hosting providers, with VPS, virtual private server providers. And you know, like you can get actually a beefy system on this, right? So for $160 a month, you can get an 8-core by 32 gig system with, you know, 3/4 of, you know, 60% of a terabyte, right? 640 gigabytes of SSD. So think of Lightsail when you want a relatively unmanaged system that's kind of a one-off for like WordPress. So it's really like, in a sense, for like private hosting, but I wouldn't use this necessarily for enterprise hosting. I would think there are other options that are probably better for that. Okay, hot and heavy on everybody's mind is containers, right? So the previous options that we just looked at, you get direct access to an operating system, and so you can host whatever you want to install on the operating system. That's what EC2, that's what the virtual machine service is good for. That's what Lightsail is good for, right? Is that they'll give you a managed and an unmanaged version of a host, a virtual machine, that you can then use to host the software that you want, right? Maximum amount of flexibility in the prior two services, maximum amount of responsibility in the prior two services. But let's say that you are looking at containers and you want to do a little operational offloading. Well, there's two services that cover containers specifically. There's actually a third that can also do containers, but we'll talk about that in a second. But it's the Elastic Container Service and the Elastic Kubernetes Service. Now, I like to talk about how the hype train right now is that Kubernetes, Kafka, and cloud, and I know it doesn't have a K, but just bear with me, right? These are the kings right now in terms of like, people are all hyped up for how we can get to this space, right? So before all that hype started around Kubernetes, Amazon had the Elastic Container Service. So you would use this if you want containers, but you don't necessarily want to deal with Kubernetes, right? That's because Amazon is using their own container agent on the virtual machines that host the containers. And so they've come up with their own proprietary system, and it can be fully managed, or you can manage the underlying virtual machines if you want to. I would highly recommend, by the way, that if you use the container service, the Elastic Container Service, that you use what's called the Fargate launch type, which means that if you do the Fargate launch type, Amazon's going to manage your underlying hosts for you. You don't have to worry about, patching and all that stuff. Oh, don't worry. It's going to ask you questions like, is it okay if I, drop this machine here and make this machine? It'll ask you questions. But this is really if you just want to host anything that runs in containers, right? And you'll notice under the hosting vehicle, I said that, well, it's containers on ? That's because we don't really know what Amazon's doing under the covers to make this work. I know there's a container agent there, but I don't necessarily have an idea of like what technology they're using. I think it's very proprietary. Now, this is a managed service. So I wouldn't say this is an infrastructure service. With Fargate in particular, I think this is a managed service. So this is like platform as a service. And so your security overhead and your operational support overhead is going to go down. Subsequently, your control and flexibility is going to go down as well, so you have less of it. It can be really less expensive, right? Far less expensive than EC2, especially if you are using containers and you're only paying for what you need. You're not paying for everything, right? So one question that I got from Stephanie, just to kind of deviate for just a second, is that she was asking me for the prior EC2 service, can you upgrade and downgrade your virtual machine without disrupting your service? And the answer to that is no. You cannot add, and practically no operating system except for like Big Iron supports the addition of CPUs and RAM on the fly easily. Doesn't mean that it can't be done. If you want to vertically resize your system, you're going to have to fail over to another instance, right, in order to accommodate that. But just to say that is that if you're running two instances of virtual machines behind a load balancer, which is abstracting away the user experience, you could fail everything over to one instance, stop and resize the other instance, and then just stop and resize the other instance once the first one's done. So there's really easy ways to solve that problem, but unfortunately there's no easy way to scale hardware underneath a running operating system that has an application on top of it. So you can't upgrade and downgrade it. You just have to do just a few extra hoops, but it's not super complicated. Quite frankly, in every environment I've been in, we do that all the time. So does that answer your question, Stephanie? Excellent. Good. So let's talk about the documentation, right? The service documentation for the container service. So one, we've got your developer guide and your API reference, kind of your standard stuff. There is, by the way, under the Elastic Container Service documentation, this great ECS workshop. And if you've never seen it before, it's a great way to get some hands-on experience, which we're really big at WebAge. We're huge on making sure that you get hands-on experience in your classes. So just know there's a lab. It will require you to have an AWS account, and it will cost you about $20 to do all the labs in here from front to back. But you will learn more about the container service than most of the people that I interact with in the world. So just know that under the documentation link for the ECS service, there is a link to the ECS workshop, which is very interactive and will show you how to use the Elastic Container Service. Remember this, if you want to host containers and you don't want to use Kubernetes, then what you're going to be looking at is you're going to be looking at the Elastic Container Service. Why would you not want to use Kubernetes? Maybe you don't want the overhead. Maybe you don't want the complication. I would say that most people now are probably going to run Kubernetes for their container service. The other thing to note is the pricing. So if you run the Fargate launch type model, it's very different than if you run the EC2 launch type model. If you run the EC2 launch type model, guess what? It just uses EC2 pricing. If you use the Fargate model, what you can see here is that there's kind of a slightly different set of pricing details, right? Because all you're paying for if you use the Fargate pricing model is the amount of memory and the amount of CPU you use. So imagine this. Your app could be sitting there running in a container on ECS. You are hosting it on Fargate. You're not using the EC2 launch model for the container service. You're using Fargate. And you're only literally paying for what you use, even though your application's sitting out there running, right? So that gets really efficient and really cheap really quickly if you're running it in containers on this service, because if your system's just sitting there idling at 1% doing like nothing tasks, then you're only going to start paying for at any substantial rate the minute the container hits like 40, 50, 60%. But even then, right, you can see there that you're only going to pay 0.04 cents per virtual CPU per hour of usage. That's pretty cheap. So keep that in mind, is that if you need to offload your operational overhead, the Elastic Container Service can be great if you're using containers and you're not yet ready to kind of poke into Kubernetes. Also remember that there's a FAQ link here. So if there's questions about pricing or how it differs from other services, it's all here. Does it support batch jobs? Is there a scheduler, et cetera, et cetera, et cetera? Just making sure that you have all the information that you need. All right. So I mentioned that the Elastic Container Service was one of the two major services for hosting containers on AWS. That's if you don't want to roll your own, because remember, you can always go back to virtual machines, right? And so the other one is the Elastic Kubernetes Service. The Elastic Kubernetes Service, if memory serves, I think came out about like 2018, maybe late 2017. And at first, it only had the EC2 option. So you didn't have Fargate. Fargate is like kind of the invisible underlying infrastructure management service that is associated with ECS. Well, I think in this last reInvent, if I remember correctly, they came out, which is in November, they came out actually with a Fargate version of Kubernetes. And so this is Kubernetes as a service, right? This isn't container orchestration as a service, which is what ECS is. This is containers with Kubernetes. So it's when you kind of need managed, managed containers, managed Kubernetes. It's one of the newest services. It does support Linux and Windows, especially if you're using Kubernetes 1.14, which supports like mixed node types with Windows as a host. So you can get operating system access if you are using the EC2 type. I would not recommend that. I would use what we call Fargate, the Fargate version of the EKS service. That allows you to not worry about the underlying virtual machines. That's what Fargate does for you. And you can host anything inside the Kubernetes service that will fit in containers, right? So if you can fit it into a container and it works for you from a microservices standpoint, then guess what? Kubernetes is your friend. By the way, what fits in containers? Microservices. Word of caution, when you hear me say the word container, right, and you are not familiar necessarily with what that is, you want to get familiar with both containerization via Docker and microservices, because containers are really made for microservices that if I were to just subjectively speculate based on my experience with it, it's probably around anywhere 4 gigs and south of memory resident footprint. You can put larger systems in there, can really kind of complicate things. And I would be very mindful if you decide to put databases in containers, right? Now, this being said, the Elastic Kubernetes service, has a minimal amount of security overhead, meaning there's going to be some, especially if you use the EC2 launch type. And actually, I think this is incorrect, actually. You have a minimal amount of security and support overhead if you use the Fargate launch type, but you also have a minimal amount of technical flexibility, even though it is Kubernetes, so you can actually put anything that containers will support in there. You're probably looking at median cost, a little bit more cost than you would deal with when it comes to the container service. And that's mainly because you got to learn how to use Kubernetes. If you don't know how to use Kubernetes, that's a new complexity sandwich that you're going to have to eat. It can be totally worth it. But just know that if you want Kubernetes, you're going to have to spend a little bit more time understanding how Kubernetes functions. Once again, I have some great documentation. And just like the ECS portion of the documentation, there is a great EKS workshop built by Brent Conner, I believe his name, from Amazon. Could be misquoting that, pulling it from memory. But there's a great EKS workshop that allows you to either choose your beginner, intermediate, or advanced flavoring, and you get to walk through the EKS ecosystem, right? So, Huma, by the way, the slide link is at the beginning of the chat. I'll repost it here just in case, just to make sure you see it. But there's the slides if you need them. So just remember, inside the EKS documentation, there's a great EKS workshop. Just like the ECS workshop, if you do that, you will know more than most of the people that I interact with around EKS. and it will cost you about $20 on your account to run through all those labs. Well, probably a little south of $20, honestly, but I'm kind of being generous, right, just in case to set expectations. By the way, just to mention this pricing for EKS, if you're using EC2 as your underlying base, then you're going to pay for that, right? You're going to pay for the EC2 consumption. But if you're using Fargate, right, then it's just like it is for the ECS page in that there's a special Fargate pricing, which means you don't pay for a virtual machine. You only pay for the memory and CPU that you're consuming. That's it. That's it. That's all you're paying for. So just keep that in mind, because this can get really cheap, really fast, because especially if your application isn't running at full speed 24/7, this can allow you to only pay for what you use on Amazon. So highly recommended that you use Fargate whenever you use ECS or whenever you use EKS. There can be limitations with Fargate, but do some research and you can find them really, really easy. All right. So we've covered some virtual machine services, EC2 and Lambda. I'm sorry, EC2 and Lightsail, right? Not Lambda, right? We've covered some container services, of which ECS, the Elastic Container Service, and the Elastic Kubernetes Service, EKS, are the two container services. But you may have heard people throwing around serverless, right? We want serverless. We want functions as a service. Well, that's where Lambda comes in. Lambda has been around for quite a number of years, and it supports a lot of direct code deployment, meaning you just upload your code to Amazon, and Lambda, you answer a few questions about what you want Lambda to do with it, like how much memory and CPU do you want? Do you want it to run close to your stuff that's in Amazon already? And then as long as it's in a format that Lambda can read and load up, like a zip file, jar file, etc., right? And it has all the dependent libraries, Lambda will go and execute it. Now, this is functions as a service. It's not really, although it can be extended to microservices. And the reason for that is that any code or function that you run here is only going to run for 15 minutes. Now, Amazon keeps increasing that because it was 5 minutes before, right? It was 600 seconds, right? And is that right? 600 seconds? Yeah, I think that's right. No, it was 300 seconds, and then I think it was 600, and now it's 900 seconds, right? So now we're up to 15 minutes worth of execution time. Now, you can call another Lambda function, so you can chain Lambda functions together if you want to keep them running, but just know that this really isn't for a 24/7 application. It's really serverless as a service. It's functions as a service. We don't really know what the app hosting vehicle is. It's probably containers. I don't really know what's going on in the back end. But I do know this. Lambda is about just hosting your code and just letting it run. It has the lowest amount of security responsibility, the lowest amount of operational responsibility, the lowest amount of control and flexibility compared to the other offerings. But the cost, it's cheap. As long as you're not running that function 24/7 at a large scale, comparatively, it's cheap. Now, if you run at scale all the time, Lambda's going to break the bank. You need to either look at the ECS or EKS service for containers, or you need to run it under EC2, right? Because otherwise, you're going to break the bank if you decide to run this 24/7 all the time. But again, don't take my word for it. Do your own proof of concept and find out. But Lambda is functions as a service. So this is not containers. This is not virtual machines. This is simple code functions that you're going to run inside of your system. Pricing for Lambda, which I'm going to skip straight to. Pricing for Lambda is just based on the execution size. Now, notice, by the way, they're using scientific notation to denote the cost because it's so far down a fraction of a penny, right? So in this particular case, right, if I want to allocate 3 gigs of memory to my function, it's 0.00000, right? That's 5 zeros, 4896. So that's like fractions of a dollar, right? Certainly fractions of a penny for every execution. So if I run that basically let's say 10,000 times, I'm probably going to get to 5 cents. That's how cheap Lambda is. But a reminder, this is functions as a service, 15-minute max execution time, and there's no data persistence here. So you got to write your data out to an external system, right? So just keep that in mind. All right, and last one, and then I'm going to pause for any questions, any other things someone wants to talk about. So the last one is Elastic Beanstalk. So Elastic Beanstalk isn't so much of an independent service. So if EC2 is the virtual machine service along with Lightsail, if ECS and EKS are the container and Kubernetes services respectively, right, used to host containers, and Lambda is used to just host functions that are going to run under 15 minutes, EBS is kind of like an orchestrator for EC2, and it's been around for a long time. So think of this as a way to get started, especially if you're a developer or someone who doesn't have to deal a whole lot with infrastructure. You could use serverless, but let's say you want a 24/7 application. Well, then what you would do is you would come into Beanstalk, you would actually run their wizard, and it will walk you through Java, PHP, and Ruby templates that then you can then use to stand up an orchestrated EC2 environment. Beanstalk is one of the oldest services out there. It's been around forever. It will do a variety of operating systems. It can host pretty much anything via code because code is the only thing that you really need to provide it other than answering some questions. But it won't support complex infrastructures. So it can be a great starting point if you are doing a simple infrastructure and you don't necessarily have a whole lot of hosting experience. But you're still going to have a lot of security overhead, some operational overhead, and you're going to get some flexibility, but not as much as you would if you were running EC2. The cost for this, by the way, is pretty much just like EC2 costs, but it tends to be more efficient because it does a lot of best practices to make things lean and auto-scale. So you can actually set a lot of that up. So Elastic Beanstalk, by the way, has no cost associated with it. The pricing for Beanstalk only deals with the EC2 instances or the database instances that it starts. So just something to keep in mind. Okay, let's bring it all together because that was a lot of talking. Let's bring it all together. And what I really want you to focus on is this right here, this second column, right? When to use. When to use, okay? So you use EC2 when you need access and you need a virtual machine. Bottom line, if you need control over the operating system, you're going to use EC2. If you need a cheaper, more simple, unmanaged virtual machine, really not used in an enterprise, right? So much, although you can, right? Just say generally not, right? Then you're going to use Lightsail. Lightsail is really like if you were going to go to DigitalOcean and get a small system or go to this, like that's what you would use Lightsail for, right? Typically hobbyists or small business websites. ECS is when you want containers, but you don't want Kubernetes. Why would you not want Kubernetes? Maybe you don't want to learn Kubernetes. Now, I think Kubernetes is probably going to end up being one of the de facto ways we deploy, so you might want to go ahead and bite that bullet. But you might already have too much on your plate, and so you just want to get a container out there, right? That being said, if you know Kubernetes is the future and you know that you need to spend some time learning it, then you might want to use the Elastic Kubernetes service. It's not as adaptable as running Kubernetes on virtual machines, a la EC2, but EKS is a great way to get started running Kubernetes when you don't have Kubernetes expertise. It's a great way to just let Amazon take care of eating the overhead of running Kubernetes instead of running your own virtual machines for that. Lambda is used for serverless. So when you need to run functions that are okay running for 15 minutes and then writing their data out and dying, that's what you're looking for. Or maybe you might want to chain Lambda functions together. Lambda is the cheapest, lowest security and support overhead, and the ease of use is through the roof. But you have the least amount of flexibility, right? So if you need like more than 3 gigs of RAM to run, it's not going to work for you. And then last but not least is if you're going to use Elastic Beanstalk to host your application when you just need a simple orchestrated virtual machine, you don't have a lot of operational expertise, and you just want to get an orchestrated EC2 system out there. That's what Elastic Beanstalk is for. It's a great place to get started, by the way. All right. So, wow, I actually kept it to an hour, like I said I would. So I kept it to an hour. So does anyone have any questions that they want to ask or give voice to? You know, anything that they want to know about what we talked about it. So Paolo, by the way, just typed a question. I'm going to answer it live, by the way, Paolo. So the live answer is that Elastic Beanstalk is used. And let me show you a representation so you can get a feel for it, right? Just so you can see it in action. I'm pretty sure I had a login. Here it is. All right, let's look at it, Beanstalk, right? So if I go in the management console, so now I'm logged into AWS, just so you know, right? So I'm logged into AWS. I happen to be in the Ohio region. Oh, that's right. Yesterday, I just happened to run a test environment for Java, right? And so what this is that if I want to come in and I just have a code base and I want to just like start a new platform, I can come in and just kind of choose my environment. So if I have a web server, I can just start a web server. If I have a worker environment, like let's say a long-running workload that I want on demand, I can choose that. And so what this is that if this was EC2, by the way, which I'll show you what that looks like, EC2 is only going to give you an operating system. So if I was running on EC2, I'm going to have to configure all of the stuff inside the operating system myself. Because the only thing EC2 is going to do for me is EC2 is just going to give me an operating system. Beanstalk allows me to use customized templates to manage my enterprise, like my worker environment, so that I can, for example, do pre-configuration on a platform. So let's say instead of using Java, let's say that I need to add a PHP application, right, into this whole equation. So I could come down here and say, you know what, I got PHP. I don't think I'm going to do any kind of custom platform because I'm going to use a pre-configured one. And let's just go ahead and do a sample configuration, right? Now, there is a more options section that allows me to make a lot more decisions to orchestrate Elastic Beanstalk. But this allows me to deploy a virtual machine that is ready for my application. That's what Beanstalk does, is it basically helps me deploy code in an automated fashion into a virtual machine. If I use EC2, I'm going to have to do all of that manually. I'm going to have to log in, copy the file over, install the software, patch it, get it to run, copy the artifact over, load it up, make sure it's working. I'm going to have to set up monitoring. If there's a data store, I got to set up the data store. Guess what? Elastic Beanstalk does all of that for you. They won't do complex configurations, but it'll do those simple templated ones. I hope I answered that one, Paulo. If I didn't, please repost. So, one of the questions I see there from Subhash is, what's the compelling reason to go to EKS? Do we know usage stats on ECS versus EKS? So why would you use Kubernetes? The main reason people are using the EKS service, the Kubernetes service versus the ECS service, is that in case you're not aware, Kubernetes has won the container orchestration, I don't know what you would call it, war, battle, conflict, right? Kubernetes is now the dominant battle cry for how you orchestrate containers in a production environment. And I say a lot of that's hype, but a lot of it is substance as well. Because the reason Kubernetes is dominating is because if you can learn how to manage it, it answers and solves a lot of problems for you. How to scale, how to auto heal, how to recover, how to deploy over across 10,000 systems, right? So the main reason to go to EKS is because it is considered to be the cloud agnostic cross-platform vehicle of the future. So people are looking at Kubernetes to allow them to kind of run their infrastructures in any cloud provider in the data center and provide the same feature set to host and run containers. Now, is that a dream? Because have we not heard this before? Wasn't Java going to be run once write once and run everywhere, right? Wasn't that going to be the thing? We would write our Java code once and it would compile on any system, right? And that turned out to be mostly true, but Kubernetes is kind of in that same initial adoption train, right? And Kubernetes is a rapidly evolving ecosystem, but that's why people are adopting Kubernetes, is they want to make their private data center and their public data centers operate very similarly. So it's providing this homogeneity where there's like a unified kind of infrastructure deployment framework, and Kubernetes has become the de facto answer for that unified infrastructure deployment framework. Now, I personally would tell you, don't buy into the hype unless you have a compelling reason, but don't ignore it either. Everything that we get hyped up about eventually dies down and it becomes the substance of our new tech tools. So I don't know if you'll remember, but back in 2006, when Amazon first published the SQS service and then S3, right? And by the way, I know the blogs say S3. No, I was there. SQS came out first. Then S3 was a fast follower, right? And when it came out, people were like, cloud is a fad, right? No one's going to put their data in cloud. We're not going to trust someone else to handle security. So Kubernetes is in that same boat. There's a lot of hype, but there is substance there. So if you feel like you're an early or mid adopter, go ahead and go after it. But if you're not really an early adopter, if your appetite for risk isn't that strong and you got other problems to solve, then you're right. You might use ECS. Does that help, Subhash? All right. Answered that one live. Awesome. Okay. All right. So it's 12:05. And as promised, I did say that we would take a break because I've been talking for about an hour. And some of you might need to take a biology break. Maybe I do too. So here's what we're going to do. Is we're going to take just a short 5-minute break because I want to keep us on track for data stores. So instead of doing the full time, let's come back at 10 after 12. So we'll come back at 12:10 and I'll pause the recording and then we will pick it back up and cover data stores, and I'll show you how to figure out which data stores to use inside of AWS. So we'll be back in 5. Thanks, everyone. All right, everyone. We are back. We're going to continue our journey moving on to data stores. Before I move forward, does anyone have any questions about anything that we covered in the prior section? Are we clear on where you would host your applications and why? Just to rehash that, main distinction, if you need a virtual machine, use the first service, first 2 services. If you're looking at containers, use the second 2 services. If you need serverless, look at Lambda. And if you're looking to orchestrate, so a more simple orchestrated way to deploy virtual machines and you just have code, you just want to deploy your code onto a virtual machine, look at Elastic Beanstalk. Good. If you can, just raise your hand really quick to make sure you can hear me. Ah, good. I know if one raises it, then you can probably all hear me. Okay, so I'm going to lower all the hands really quick just to make sure we're clear. If you are a database data store administrator for either RDBMS, NoSQL, Elasticsearch, or Graph, can you please raise your hand for me? Yes, I have one, and then there's 2. Awesome. Okay, good. And potentially a third. I didn't see that last name that popped up. So, excellent. So if you are an administrator, this is going to be useful. I am not going to get into brass tacks around the different data stores. So if I apologize if I offend you with the simplicity, but I am going to keep things relatively superficial simply because there's a lot of services here. Oh, Jonathan, you're one too. Excellent. Okay. So let's talk about data stores. So just a reminder, we're mainly going to talk about RDS, DynamoDB, Elasticache, Neptune, and Redshift, and we're going to talk about the Cassandra service, the Elasticsearch service, and the DocumentDB service. Just to be clear, I'm not going to talk about the Ledger service. I'm not going to talk about the Ledger service because, one, just to be forthright, I've never used it in production. I don't like talking about things I have never used in production. 2, it's relatively new, and 3, it's a very specialized use case. But if you want to know more about it, it's out there. You can find it out on Amazon's webpage. But it's not really an application level data store per se. That's kind of an interesting statement, but it's not in our purview today. The other thing I want to mention is that I'm not going to talk about cloud search. Here's why. Cloud search was Amazon's first foray into running search as a service. And so it was based, I believe, on Solr instead of Elasticsearch. And I have not seen an announcement for cloud search since 2015. Now, in internet years, which I like to think of as like dog years, which means that every 7 years on the internet is like 1 year in real life. That means that that cloud search has not received really any kind of like significant, update or enhancement in like 28 years. Really, it's just 4, but 28 years, right? So most people are focusing on Elasticsearch. I think in terms of like who is dominating the space, Elasticsearch, both its open source version is dominating that space. Mainly people who have Solr are still using Solr with Zookeeper, but you don't see a lot of that anymore. Most people are focusing on Elasticsearch as their search engine. So, yeah. So we're not going to talk about cloud search. All right. Now you might say, Michael, is there an error in your slides? Because I thought you were going to teach us how to, bottle fame and brew glory and put a stopper in death. That's a Hogwarts reference, by the way, Harry Potter. No. So just so you know, when we're talking about databases, or any application really, virtual machines are still a strong possibility, right? You want to roll your own MS SQL server or Oracle rack system, or you want to use an obscure like OrientDB or Influx or some variation thereof, you can always use a virtual machine to host your database. Now, that will be the most expensive, not from an AWS perspective, but from an overhead perspective. It will cost you more. So just know that you're going to get more responsibility, the most amount of flexibility, and the most amount of options if you run a virtual machine. But just know you're going to be responsible for all of that. So if you're okay with that and you've got that down to a science, awesome. Use virtual machines to run your database. Just know that most people are seeking to avoid that. All right. Well, then let's talk about the most commonly used data store since the late 1970s, 1980s, right? Which is a relational database, RDBMSs, right? So RDS, which is Amazon's relational database service, first of all, is one of their oldest services, which is awesome. They did a lot of iterations on it, right? It is constantly evolving, and it supports well-known databases like MS SQL, Oracle, MySQL, Postgres, and MariaDB. Now, there's also Aurora. Aurora is just the cloud flavor of MySQL and Postgres, right? And by the way, it's typically 3 to 5 times faster depending on which engine you use. But if you use the same data set and the same hardware and do an apples-to-apples comparison of Aurora versus, right, a system running in EC2, it's going to be 3 to 5 times faster to use Aurora. So just know, right, that if you have to use MySQL and or Postgres and Aurora is compatible with your version, you probably want to look at Aurora for your versions of MySQL and Postgres, right? But bottom line is that you use the relational database service when you're using SQL and you need a schemaed transactional data store. Now, a couple limitations. If you're going to host your data here, you are predominantly going to be single node. It does not support multi-node masters. That doesn't mean that you can't get asynchronous, replicated failover where you have a primary and a secondary. You can. It doesn't mean that you can't have up to 16 read replicas, which will scale your reads tremendously. Doesn't mean you can't get 16 read replicas. You can, or 15 actually. Sorry, right? You can, right? So, but it does not support clustering. So you're not going to run Oracle Rack. You're not going to do log shipping. If you need that, then you're going to have to run that in a virtual machine. And just know multicast is flaky on the cloud network. So if you're using Oracle RAC and still it's relying on that, you might run into some issues, right? But you use this service when you need a known technology, you need SQL, and you need an acidic, right, data store. So you can actually scale the system vertically, like you could stop a database, upsize it, and then scale it up, or you can horizontally scale with read replicas, right? So you have a lot of scale options. This is the least amount of security overhead overall, least amount of support. You do have some infrastructure control, but it's light, and it is going to cost you, a little bit to use RDS. The documentation for RDS is spectacular. Where is it? There it is. So you've got RDS, you've got the Aurora subflavors. You can also, by the way, run RDS in your data center as a virtual machine. So if you want to download it to VMware, you can do that as well. And there's a bunch of references here. No particular awesome labs, but there are labs out there for you to do. The other thing is that the pricing for RDS is based on the engine and the size of the system that you choose. So for example, these are database instance types, right? And you can get the pricing for these by not only looking here, but you can also go to Amazon, the ec2instances.info, so that website that I posted earlier, which I'm going to post again, ec2instances.info. And if you click on the RDS tab over here, guess what? If you click on the RDS tab, you can actually get guidance on your RDS sizes for your relational database. And by the way, they do have matching sizes, like for the T3 family, which is the proof of concept burstable family. They have it for a memory instance. So if you're looking for the R4 family, which is very memory intensive relative to the CPUs. If you're looking for the compute heavy instances, well, I don't see those there. Huh, well, maybe that's not an option. So just know you don't have every option that you have under EC2 available here, but you do have plenty of options available for you to expound upon. Like here is, for example, the general purpose family, which is the M family, right? Which is a good blend of CPU and memory, like it's usually a 1-to-4 ratio. So just know if you ever need to come in here and take a look at possible costs, you can look in here. I see some costs are missing. I'm kind of wondering why that is. I'm wondering if it's not erroring out, but typically they're listed. Oh, see some errors here. Anyway, you can also go look on the pricing page if you need it. So again, this is a relational database service, so use it when you need a database. That's the bottom line. Okay, so let's say that you want to look at a NoSQL service and you're not necessarily wed to MongoDB or Cassandra. You're just looking for a scalable NoSQL service that can just literally handle a table with keys and values, right? You're just still looking for a key value store. That's really what you're looking for. You're looking for something that will handle a blob of data based on a key, right? This is where DynamoDB comes in. DynamoDB is one of the older services. It's been around for a minute inside of AWS. I think it was 2012. Did I actually put a date on there? I think it was 2012 when it came out. Could be wrong. And with DynamoDB, you can have tables, which can have indexes on top of them. You can do triggers on the tables, but it's schemaless, so it doesn't require a schema. You can make your schema as you go with your table. Every table can be scaled horizontally using what they call read and write capacity units. So you can tell Amazon how much you want to pay for the table to perform, or you can turn on demand, which is kind of like this form of auto scaling, which will scale the table up and down based on the number of requests that hit it, right? So it does. NoSQL typically does not support strong transactional consistency. You can force strong consistency if you want at the cost of a little bit of performance inside of DynamoDB. And you can also, by the way, do a strong in-memory cache option, which makes DynamoDB ridiculously fast. You will pay for that, but it will make it exceptionally fast. You have almost no security responsibility, when you use DynamoDB. You just need to make sure that the only people who can access the table are the people you say. You have almost a minimal amount of support overhead because you're not required for patching or anything else along those lines. With RDS, there is some patching with the relational database service. With DynamoDB, you are not responsible for the underlying infrastructure. You put data in, answer a few questions, and then you just go. That's it. Now, as a result, you have the least amount of infrastructure control, and you have the least amount of technical flexibility. And the costs for what you get are pretty low, and so is your operational, so your manpower hours are low as well. You don't have to have anybody from operations manage this for you, right? You might have them monitoring it, but you don't need them to do anything with it. How does pricing on this work? Well, here's what it looks like. So if you do on-demand capacity, right, you can dive in and you're going to be like pay on per gigabyte per month. So in this case, right, if a write request unit, right, you're going to pay $1.25 per million write request units, right? So for a million write request units, you're going to pay $1.25, right, which is excellent. For reads, you're just going to pay 25 cents per million read request units that you ask for, right? And that's like per request, I believe, per hour, if I remember correctly. So just know that this can actually get pretty cheap, but if you add options like the DynamoDB accelerator, right, which requires you to choose some instance types, you start adding global tables, you start adding in backups and restores, things can start to pile up. So you just want to make sure that you run the AWS Simply Monthly Calculator that I was showing you before. If you look down here, there's a DynamoDB section. So if I actually come back up here and remove the system, my bill goes back to 0. I can go to the Simple Monthly Calculator and I can say, look, for a 1 terabyte data set, right, and with the item size being about, let's say 3 kilobytes, and I'm going to do an eventually consistent read set, I'm going to pay about $274 a month for that table, right? And you can add different things like the total number of items that reads in millions. Let's say it's pretty even, and then you're seeing a nominal increase, right? For millions of items read per month, millions. So if you're looking for a NoSQL blob as a platform service, NoSQL is your friend. This is proprietary to Amazon, even though it's based on a pretty public paper, a Dynamo paper. React, by the way, is the open source analog. So it's written in Erlang. I got to tell you, I once ran React in production. It's an incredible pain. Hopefully it's gotten better since I last touched it about 7 or 8 years ago, right? But just know that this is one of the best services that Amazon has, from my perspective, for data. Just checking for questions. Everybody's looking good. All right. Good. Okay. So here I am on the Elasticache slide, and Elasticache is really an in-memory data cache, in-memory data store as a service platform. It can run either Redis or memcached, right? And so, notice, by the way, that has different from the app hosting conversation. The data store conversation is very much focused on the type of technology that you're familiar with, right? We are surfacing a lot of specific technologies in the data store section that will help you pick what it is that you're familiar with or what you're looking for. So in this case, Elasticache is really just a memcached or a Redis database cluster. And you can cluster. And like Redis, for example, is far more than just an application cache, but it is its primary use case. So, just know that Redis is basically a really sophisticated in-memory data store. And so you can use it for more than just, application caching. This has been around for, it's one of the older services. I think it's 8 to 10 years old, if I remember correctly. And you definitely want to use it when you need a fast distributed in-memory cache. You do scale based on nodes in the cluster, and you can grow clusters to huge sizes, terabytes easily of size for some of these clusters if you need a huge in-memory resident database. You will pay for that. It will cost you. And so subsequently, I consider Elasticache one of the more costly services that you can get for what you get, right? So for what you pay for, I think it's the value is there, but it's a little slimmer. Your security overhead's low. Your operational support overhead, I think, is a little higher. Your control and flexibility are pretty low inside of Elasticache. If we look at the documentation set, you'll find, sorry, just closing this down really quick so everybody can see everything. You'll find that it's a very slim documentation set because it covers Redis and Memcache, so if you need to go through the user guides for that. But the other thing is that you'll find pricing is not too elaborate, right? If you want to choose an EC2 style instance that has, excuse me, 2 CPUs and let's say just shy of like a little over 3 gigs of RAM of memory, right? That's going to cost you, like that's going to be the T2 system. And so you'll have to use the simple monthly calculator to figure all this out. But, you know, like if we were to go to the simple monthly calculator to see what this would look like for Elasticache, I think what you'd see is that let's choose a small system just to get a feel for pricing, right? Is that over here on the left, we're going to choose Elasticache. We're going to stay in Virginia. Let's say that we're going to do an on-demand cache cluster with, let's say, 1 node, 100% utilized, and we're going to use the smallest of the T-series size, right? Let's say we do the medium. We're going to spend $50 for that. Now to go back, the medium, by the way, over here is a 2x3 system, so not that big. By the way, where's the T3? I don't see the T3 in here because the calculator is missing a few things. But if I go for the larger system, let's say I'm looking at the memory authorized system and this is the 24 large. If I come in here and I choose the 24 large system, right, which is the R5 24 large, instead I'm going to pay $8,300 for that a month, right? So just something to keep in mind is that I think Elasticache can get expensive really fast, so make sure you're being very judicious and smart about how you're doing application cache. There's a great fact here about how to do auto discovery and version management, and how you do read replicas and backup in the store. It does do encryption, so just know you've got tons of really great options for managing your Elasticache system. The FAQ will explain a lot of it for you, the FAQ. Checking for questions. Doesn't seem like there's anything here. Good. All right. So we've covered a relational database service, and that's called RDS in Amazon. We've covered a general NoSQL service, which is DynamoDB, right? So if you just need general, like key value store, document store, like you're going to look at DynamoDB for that. We've talked about application caching, which is what Elasticache is for. And there's 2 flavors of that. There's Memcache and there's Redis, right? And then this is Neptune. So Neptune, if memory serves, came back out in like 2018, early 2018. It is based off of Neo4j, which is probably the most popular graph database in the world. And you might say, Michael, well, I know what an RDBMS is. I have an idea of what NoSQL is. I even know what you mean when you say a search database. What do you mean when you say a graph database? Well, a graph database is interesting because I'll be frank, I don't know that I've ever been able to explain it exceptionally well. But the thing that you need to know about a graph database, it's where the relationships of the data are most of the value of those graph databases. Meaning that you're going to be asked a lot of questions about how Howard relates to Sam and the chain of events that led them to get there, right? So traversing those relationships is very fast, and that's what the graph databases are focused on. They're focused more on the relationships between the data sets. So you use them a lot for fraud detection or for recommendations engines or for, you know, kind of like social media style connections. That's what graph databases are built for. You're just going to have to take that at face value because I'm not even sure I could explain it deeper than that because I've never actually implemented one from an application feature set. I've only supported them in production. So if you or your developers, your programmers are asking for a graph database, Neptune is out there. It is way cheaper than a comparable Neo4j license, but it does not have the features that Neo4j has. So you will not get the full awesome feature set that Neo4j has, but if you don't need that, which we didn't when we were doing our project, then Neptune will work great for you. So Just know that Neptune is going to function very similarly to an RDBMS, in that you're going to have to like choose your sizes. Notice, by the way, you can tell that Neptune is kind of new, because if you're looking at my screen, you can see that there's only one user guide. It doesn't have a whole lot of documentation yet. So even though it's like approaching like I think 18 months or 2 years old, it's not yet fully fleshed out. Pricing, by the way, is based on instance sizes. So just like it was when you were looking at the RDBMS or Elasticache, we have these database sizes. You can see that, you know, here it is, sized per hour. They're kind of missing the memory footprint and whatnot, which is kind of a little interesting. But you can get a feel, like you'll have to look at the AWS monthly calculator, but you can get a feel for like the size of the system. Notice that at most, if you had the largest possible, you're going to pay about $8 an hour, which, you know, translated, just to be upfront about that, that is going to be about $5,000 or $6,000 a month. So make sure that you're using a graph database intentionally. You'll be shocked at the number of graph database-like features that are in most of the older RDBMS engines like Postgres or MySQL. So just know, right? Use graph when you really need to. It's a great fact for Neptune, if you ever need to read it. Like, what popular graph languages does it support, for example? Like, it supports Tinkerpop and the SparkQL language, right? So if you're looking for like details, it's in the fact. Ooh, let's see what the pricing option says. How much does it cost? See the pricing page. Oh, we were just here. That's funny. Neptune is very similar to the other managed services in that there's low security overhead, low support, but you don't have a whole lot of flexibility and control as a result. I think this is expensive compared to what you get, so make sure you're using a graph database intentionally, right? All right, so we've talked about an RDBMS via RDS. We've talked about a general NoSQL service like DynamoDB. We've talked about Elasticache, which is mainly used for caching of some type, but it also has Redis inside of it, so it could be an in-memory data store as well. We talked about Neptune, the graph database service. So you use that when you need graph database. If you don't know what that is or don't need it, then don't look at it. And then this is Redshift. Redshift is another like older service. It's been around, I think, for almost 10 years now. It was originally based on Postgres 8.x, and it has evolved tremendously, right, inside of AWS. Think of Amazon's AWS Redshift when you need a data warehouse. This is for a large data set of predominantly cold data, not glacial data, but colder data that you need to run like reports against. So this is not really for online OLTP. This is more for OLAP. So this is when you want to maintain a large data set that you're going to run like large infrequent batches of reports against. Redshift, by the way, can support clusters of up to 128 nodes. It's ridiculous how large, how much like compute power Redshift can handle, especially because they introduced a new type, the RX3 or RA3, if I remember correctly, RA3 node type, that allows you to specify compute and storage very much independently. But 128 nodes of compute power is ridiculously significant. So that represents a pretty large memory footprint, a lot of compute power. And storage, by the way, can scale independently. So I think Amazon will tell you that Redshift can support, 3 petabyte data stores. So just be aware that that's the case. It's pretty impressive and amazing. So, if you need a data warehouse, then Redshift's going to be your friend. The docs on Redshift, the documents are pretty comprehensive. So getting started, you got the cluster management guide, right? I know it looks relatively slim. There's no necessarily like lab for this, but it's got a great developer guide. This is all very mature documentation, right? Rock solid. Pricing basically follows like the node differentiation, right? Meaning that, hey, if I need a DC2 or an RA3, I'm going to pay $13 an hour for the largest system they possibly have. If I need to be more focused on compute or more focused on storage, then I'll use the DC or DS2 types as chosen. notice that their offerings are a little slimmer, but they give very clear t-shirt sizes for virtual CPUs to memory ratios. All right, just checking for questions. Excuse me, coughing in everybody's ear. There is a FAQ out there. Awesome, talks about billing, scalability, concurrency, querying analytics. So there's a bunch of great information out here if you're looking for more details on how to use Redshift. You do get Redshift 2 months for free, especially if you're kicking into a free tier where you're like free account. You're free, by the way, when you create a free account on Amazon, like under like your personal name, please adhere to your company's enterprise restrictions on creating AWS accounts if you're using their email address. But if you're using your own email address and you create a free account, Amazon will give you a bunch of free stuff. Like they'll give you a free, 5 gigabytes a month of S3 storage. They'll give you 1 million Lambda executions. So just know that when you create your own account, even though you got to put a credit card behind it, you get to control costs, and Amazon will give you a bunch of free stuff. So that's Redshift. So think about data warehousing as a service. Okay. So now we're on to DocumentDB. So if RDS is the relational database service, DynamoDB is the general NoSQL service, Elasticache is the Redis or Memcached application caching service, Neptune is the graph service, and Redshift is the data warehousing service, DocumentDB is a relatively newer service that is focused on MongoDB. So think of this as the service that you want to do when you want a big MongoDB cluster, like a bigger one, right? And you don't want to have to manage the whole thing, right? Think of it as like managed MongoDB, because it is managed service, right? So it is based on MongoDB, but it's really for larger nodes, so I think that's when the threshold gets hit. So if you need a NoSQL document data store like Mongo, then you want to use the DocumentDB service, right? It is based on nodes in a cluster, so just like the other systems, you add nodes to add compute, memory, and storage power. The cost, I think, is a little more, and I think it's meant to be a little bit more because these are really for bigger MongoDB clusters than you would kind of like normally run like when you're just getting started. Your security overhead's low, support overhead's relatively middling, and you have some infrastructure control, but your flexibility is a little less. When we look at what's going on in the documentation, it's pretty light. Just like Neptune, MongoDB is 1 or 2 years old. And actually, I think DocumentDB just got announced last year. I couldn't be misquoting that. But there is a good developer guide, and when you're familiar with MongoDB, it has a lot of compatibility, so a lot of your MongoDB setup will work here. Pricing-wise, when you use MongoDB, right, you get the same constraints of like, well, am I using a DBR5 large, which is 0.27 cents an hour, or am I using something larger and therefore more costly, right? So pricing is listed right on their pricing page, and you just need to use what you need for your application. Great FAQ, right? For everything from hardware scaling, backup and restore, performance, etc. So just know that there is great documentation out there for DocumentDB. Think MongoDB as a service. That's what you want to use DocumentDB for. Last, well, this thing looks like it's out of date. So I'm gonna do this one on the fly. I'll update those slides and make sure we get updates out to you. So this is Cassandra. This is managed Cassandra as a service, right? So again, this is based on nodes, just like other instances. Oh wow, and those links are wrong too. I wonder how that happened. So if you need Cassandra, which is a like more columnarily focused KV store, so columnar KV store, then this is where you're going to look at Cassandra. It has a lot of flexibility, like capability, very popular in the ecosystem. This is a Cassandra managed service. And just like MongoDB, if you were to compare the previous stats on MongoDB, the security overhead is pretty light here, but the technical flexibility is inversely proportional, right? So you don't have as much infrastructure control or flexibility. And I think the cost is probably comparable to a MongoDB service because this is more for larger Cassandra instances. Let's go take a look at the documentation. So AWS Cassandra. Let's just look at documentation. So here is the managed Cassandra documentation. And oops, I clicked on the wrong thing. Right? Here's the developer guide. Here is the Cassandra query language reference for the managed Cassandra service, right? And if you go and read the documentation, what you'll see is like just the standard stuff that you would expect. Use cases, the reference, security, quotas, etc. If you then decide, well, where is the AWS Cassandra pricing? And I'll make sure I update those pieces. If you look at pricing, right, the pricing for Cassandra is a little different in that it probably more closely matches DynamoDB than it does, say, RDS. So Cassandra has an on-demand throughput model, which means that you can really just let AWS manage this for you. You don't have to pick a t-shirt size. You just set up a read unit and a write unit, much like you would with DynamoDB. You just tell Amazon what your capacity needs are. And what will happen is that on the back end, Amazon will take care of those capacity needs for you. So it's not like MongoDB or Elastic Cache or Redshift or RDS. It's more like DynamoDB, where you just basically say, look, I just need you to provide some on-demand capacity mode. It will, in the future, support a provision capacity throughput, which is very similar to how DynamoDB originally did its provisioned capacity, but it doesn't have it out yet, so it's not available at this point. And this is Cassandra that we're talking about. Okay, last but not least is that we've talked about RDS has the relational database service. We've talked about DynamoDB as the general, highly scalable, highly managed NoSQL service. We've talked about Elastic Cache has this is the application caching service. We've talked about Neptune has the graph database. We've talked about Redshift has the data warehousing service. We've talked about DocumentDB has the MongoDB style data store service. And we've talked about managed Cassandra, right? The managed Cassandra service has a Cassandra style managed service. Last but not least is Elasticsearch. Elasticsearch is AWS's search as a service option, meaning if you need a data store that does fuzzy search, linguistic search, semantic search really well, then Elasticsearch is going to be your friend. They, by the way, just so you're aware, have published what they call the Open Distro, which is an enterprise version of Elasticsearch with all of these features bundled in. Normally, by the way, you have to pay for these with Elastic in order to get access to this. But Amazon decided to fork off their own version. There is not a high change rate for it, but they do a good job of keeping up with enterprise versions that you might want. It is 100% open source. So just know that you can download this and use it. I'm a big fan of Elastic as a company, but I also like competition. So I think this is healthy for Elastic in the long run. This works also on clusters. So you have to kind of like pick a size and number, very similar to how RDS and the other systems function. They do have an ultra warm version, which means that you can pay less to have a slightly slower system for cheaper access. It's been around for a minute. You want to use this when you need Elasticsearch and Kibana. It scales based on nodes. This does cost, I think, a little bit more, requires a little bit more operational overhead. But if you need Elasticsearch and you don't want to manage it yourself, you want to pay for licensing, this is a great option. Notice that all it really has is the developer guide. The reason that it only has a developer guide, by the way, is that most of your Elasticsearch documentation will apply to this. So Amazon didn't really feel a need to write a whole lot of documentation because Elasticsearch is a pretty well-known data store. It's been around for about 8 years now. To show what that looks like, right? If you reserve any instances, the on-demand pricing, assuming that my page will load down just in case this is causing a problem. So here, we're back to the Elasticsearch pricing. You'll see the different sizes of systems that you can choose. And like it can get as cheap as like 0.018 cents per hour to have a 1 gig, 1 virtual CPU system. You can use compute optimized systems, memory optimized systems, you can use storage optimized systems. And if you want to get a contract with Amazon, you can get even cheaper pricing, right? So just know. Great fact here for Elasticsearch, covering everything from pricing, security, SLAs, the preview for Ultra Warm, which has just come out, right? So just know you want this service when you want search. All right, let's bring it all together. So, here's the deal. When are you going to use these technologies? Well, by the way, I'm a big fan of using things that you're familiar with and that your team is passionate about. So if you got a kind of team that wants to try new cutting edge technologies, these managed services are a great way to do it without breaking the operational like overhead bucket, right? So mainly it has a difference from app hosting, where you might like be looking at any operating system or anything that can host containers or anything that runs serverless. This is very much technology dependent, right? So if you're using a traditional RDBMS, you're going to use RDS. If you want general NoSQL, it's DynamoDB. If you need search, it's going to be Elasticsearch. If you want a data warehouse, then you're going to use Redshift. If you want Graph, it's Neptune. If you want an app cache, it's going to be Elasticsearch. And if you're using Mongo and Cassandra, you're going to use those particular services. So unlike the app hosting conversation, the data store conversation is a much different conversation because it's just going to center on what you already know. Now, in looking at this, DynamoDB and Managed Cassandra are typically going to be your cheaper options because they auto-scale automatically. They have an on-demand feature, which means you're going to pay for if you use them, and when you're not using them, you're really not going to pay anything. You might pay for storage, which is cheap, right? But compute-wise, it's going to scale up and down, right? By contrast, if you're using EC2 to roll your own, that's typically going to be the most expensive, not just in AWS costs, but in manpower hours used to log, monitor, manage, patch, scale, respond, secure. EC2 is going to be the most expensive option generally, not just from AWS, but when you couple in everything else needed to manage it. RDS, Elastic Cache, Neptune, and Redshift, along with DocumentDB and Elasticsearch, are all going to be comparably like less than a rolled EC2 instance, but not as cheap as, say, like Managed Cassandra or DynamoDB, because you're not going to auto-scale those systems per se. You're going to have to actually grab machines that you're going to add to the cluster. And so it's not a dynamic behind-the-scenes auto-scaling procedure. Now, the security overhead for almost everything except for RDS is going to be significantly less. Your technical flexibility for almost everything except for EC2 and RDS is going to be really low because you're not going to get a lot of technical flexibility with these managed services. Your support overhead is going to be pretty low. I think Elastic Cache has a little bit more support overhead, has the DocumentDB and Neptune. But the other systems like DynamoDB and Redshift, if you look in that column, along with Cassandra and Elasticsearch, their operational and support overhead is actually pretty low. Your control, like you're in a sense like almost like coupled with your technical flexibility, your ability to control the environment is going to be a lot higher with EC2. And of course, with a lot of the other managed services, you have almost no control over the infrastructure other than choosing sizing. So there's your rubric. So just to check, are there any questions about the data store conversation? Anything that anyone was unclear about which service to use for which reason? Anything that wasn't clear around data stores? All right. Any questions at all about any of the app hosting options that we talked about? Well, Paolo, it means, what do you mean by big data solution? Give me an idea of what it is that you're looking for. Are you looking for like MapReduce big data? Are you looking for machine learning style big data options? What are you interested in? Oh, so the equivalent to MapReduce Hadoop would be a service called AWS Elastic MapReduce, or EMR is the short name. And so EMR also allows you to get access to the operating system, but EMR allows you to scale just huge distributed batch jobs, right? And so you can run Apache Spark, Hadoop, Presto, HBase, Hive, other big data frameworks. And there's a whole ecosystem of big data, right? Which, just so you know, there's a big data class on AWS. If you're ever interested, WebAge offers it as part of being a training partner with them. But just know there are big data options. If you really want to dive in to big data from a training perspective and see what EMR and all that is about, you can do an AWS big data training. And they have some great digital training. There we go. Right, you can find a class. They also have some digital training underneath their training enterprise setup, but you can find big data, like an AWS big data ecosystem class, basically. But EMR is the product that runs Spark, Hadoop, HBase, Presto, Hive, and all that other stuff. So you would dive into that if you wanted to know more. There's a pricing page. Here's how you can talk about EMR workloads, features, and then how you would get started in other resources, right? So I would start there. Excellent. Good. Any other questions? One reminder, and by the way, feel free to type in more questions, is that, we did talk about data stores, we did talk about app hosting. Know that a lot of this changes pretty rapidly because Amazon is doing a lot of deploys a day. So just be aware. Make sure you check the links in the documentation. Huge feature sets don't change. It's not like the Cassandra managed service is all going to change to the Couch-based managed service. That doesn't happen very often. Major services take time to develop and release. If you want to know more, you can click on the link inside the slide to see scheduled classes. You can go to Architecting on AWS or Developing on AWS, which are 2 classes that we have showing up in February. We teach the entire ecosystem for AWS. So, anything you're looking for, we probably have. And Amazon, there are tons of resources out there for Amazon. So feel free to poke around. Pick an interest. Pick one thing that caught your interest today and dive into it and stick with it, right? Open up a free account and start unraveling it. If you want to contact us, we're the next to last page inside the slide deck. You can go to webagesolutions.com if you're looking for more information. And of course, if you're looking for me, I'm Michael.Forrester. That's with 2 R's in the middle, right? At webagesolutions.com. You can count me at LinkedIn at the Performing Pro under LinkedIn, or you can always hit me on Twitter at @PeopleForrester. I'm more of a lurker than I am a poster, but you can catch me out there on a regular basis. So we're ending a little earlier, so I'm going to linger for the next 5 minutes or so to answer any outstanding questions. But technically, that is the end of our webinar today. If you have any other questions or anything else you want me to talk about, I'll be hanging around for the next few minutes, but it's been a pleasure. So thank you for your attendance and your participation and your questions, and I look forward to catching you at our next webinar. Thanks, everyone.